After we complete the discussion of the linked list implementation for the list topic, it is time for us to take a look of a full code. How do we combine all of those functions together so that I develop a lab for you guys to have some practice. One thing you may notice that CSCI 2320 data structure class is very different from CS1 and 2 because CS1 and 2 have labs. For data structure, this is how we're going to conduct the labs. So in the end of the topic, I have designed something for you guys to do some practice. I will not be able to do the basic debugs with you together line by line, code by code, because you should have some basic trainings in your CS1 and CS2 already, and that's why CS2 is the prerequisite for this class. I would, though, be able to answer some of your questions by saying that why this output is not working, why this function is giving me something else than I expected. So that's something we can discuss. However, I will not try to debug with you, sitting next to you, looking through your code line by line, and then tell you that you miss a semicolon. These are not the things that we will be able to conduct for you guys. So let's take a look at this code. The full linked list implementation will starting with the general things, include IO stream using namespace std. Then we need to define the node. This is the code that gives you the ideas of the data part as well as the next part for every single node that you have in declare. Then we try to put everything, the constructor, empty function, traverse function, insert and delete functions into what we call a pointer list class. Of course, this is the name that can be given by any user or any programmer. And here, it has a public point and as well as the private part. For the private part, it simply defines a pointer, which is top, and you all know how important it is for this pointer. So in the beginning, for the pointer list, when you try to call a pointer list, this is the constructor going to be, you make top equal to null. If it is empty, then top is equal to null, obviously. So that will give you the function of the empty function. If it is not null, then that means there's something over there. Inside of your insert operation, it takes two parameters. One is the element, the other one is the position. Before we do anything, we prepare the space by giving the new node, and then we try to remember where that location is going to be. And then we put the data part, we put the element into the data part. So that's the preparation work. If top equal to null means it's empty, and the position equal to 0, indicating that you want to insert the very first item into an empty linked list, then these two lines will going to make that happen. You make the next part equal to null and then top equal to new PTR. If it is not null, then that means there's already something in the linked list. And the position you want to insert again is 0. So what that will do is that you want to insert something in the very beginning of an existing linked list. So the next new PTR next will equal to the current top and make top equal to new PTR. If that's not the case, which means that you want to insert a node into any point inside of the existing linked list, then we will go through the process finding the pre-PTR, so that we need to define a pre-PTR and then make it equal to top. So it will start searching from the beginning, go through the for loop until we find the right pre-PTR, and then we can do the magic, making new PTR next equals to pre-PTR next, and then make pre-PTR next equal to new PTR, so that they will make the proper linkage for the new elements to do the insert. For the remove or the delete function, all it takes is one parameter, which is the position. If position equal to 0, that means you want to delete something in the very beginning. What that would need to do is make PTR equals to top, because that's exactly the items you want to do the deletion. Top equal to pre-PTR equal to PTR next equal to the second item that is looking right now, and then you free the space, and basically you have successfully deleted the very first node. Otherwise, we need to go through the loop and then find the pre-PTR again, so that once we find the pre-PTR, we can say that PTR is the next one, and then we will be able to bypass that. So pre-PTR next equal to PTR next, and then we need to free the space. Once all of these are done, we can look through the insert and the delete operation. For the print function, this is very straightforward. You create a temp pointer, make it equals to the top, and then as long as it is non-null, which means it's not go through the end of it, you output the data part. So this is in the class, this is the first time you see how do we use this special symbol to access something inside of your class definition. So, and then we're going to make temp equal to temp next, or you will keep moving until the end of it. Here, the while loop is something very useful for the print function, because you don't know how many items you have. Unlike the insert and delete. Insert and delete, because you know exactly which position that you want to do the insert or delete, so you use a for loop. In here, because we don't know how many elements that we need to travel, so while loop is the one that we use in the print function. This is going to be very important for your upcoming project 1. So that make sure you understand the differences. Why one is using the for loop, the other one is using the while loop. So in the main function, this is where we are able to call everything that works together. So in the beginning, you're going to create a new class, which is the class that we have defined for the linked list implementation, which is called pointer list. So we create a new one, just like what we did before, create a pointer to remember where this whole thing going to be. So inside of that structure, S1 will be able to call the insert function. So you can see that this is the name that we provided, and then you will look into the insert function one by one. So ideally, you should understand that we want to insert the element of 10 at the very first location, 20 at the next location, 30 at the next location, 40 at the next location. Once that is done, we try to output to see if they are successfully being connected like this. And then we insert another several items by giving some random locations, and we will be able to see is that going to be a successful insert or not, and we can still output the things over there. And after that, we try to remove something, and then every time we remove some elements, we want to take a look if that is a successfully removed. So you can see that this whole code is actually a code that's executable. So if we go into copy and paste inside of the Visual Studio, and then we're going to build up the solution, it should give you a successfully built. So we have a successful build over here. So now if we try to run it, Control F5, you will be able to see all the inputs over here. So you see that in the beginning, what we're going to do over here is that let me pull out that output. So in the beginning, we try to insert 10, 20, 30, and 40 one by one. So that's going to be our first output. So we do have the correct output. And then we try to do insert 50 at the first location. So you see that 50 is inserted in the front of it. And then we want to insert 60 after the third location. So you can see that after 50 is being inserted, we will be able to insert 60 at the third after the third location. And then we try to insert 70 after the fifth location. So that's why the second output of the print is going to give you this output over here. After that, we will try to remove some items, and then by given the positions, they are this is showing that they have been successfully. First one is remove the item after the second location. So you can see that originally is 50, 10, 20. After the second location, 20 is the one that we want to do the remove. So we have successfully removed that. And then we try to remove the item after the first location, which is 10. So you can see the next output, 10 is gone. And then we try to delete the item after the third element, so 70 is the one that has been deleted. Therefore, you can see that this piece of code will give you the full functionalities of what we have discussed about the linked list. This lab is not going to be some crazy difficult lab. The lab is asked you to fully understand the code, and then Really, seriously, you need to understand. I want you to understand the code first. You are be able to run the code doesn't mean you understand it. You really need to look into one by one, try to trace the code. For example, when S1 of the insert 10 and 0 is happening, you need to go into the insert function and then try to see 10 and 0. So what's happening over here and what is happening over here. So that you will be able to have a full understanding of what is the exact transitions from each line of the code and what is the outputs of that. Once this is done, once you understand it, I want you to just randomly add 5 more inserts into the main function. Whatever you try to do, make it interesting. Try to look into what is the expecting output that you think it is and what is the program's output. And then after that, I want you to do 5 more remove so that you can add more removes over here and then try to see the output of your code. So this is for you to say have fun, for you to really fully understand the whole ideas. You don't need to submit anything in this lab. In the following upcoming next video about talking about project number 1, there is going to be something related to this lab assignment. But for this lab assignment itself, you do not need to submit anything. So I just want you to copy and paste the code, play with it, try to fully understand what is going on over here, and that is what I want you guys to do for this lab.